Good day once again. My name is Graphics. Today we want to solve a problem in trigonometry where we are told to prove the following identities. It says that we should prove that sec theta minus 1 all over sine square theta is equals to sec theta all over 1 plus cos theta. Now in this case, if you want to solve question like this, just remember something. We have two different sides of the equation. We have the left hand side and we also have the right hand side. Now the right hand side is our answer. It is what we are to get. The left hand side is the question. Now we want to prove how the question becomes the answer. So you are focusing on the left hand side, not on the right hand side. So as I'm solving, I'm working only with the left hand side. Is that okay? Now let's start. If you look at the numerator and the denominator here, the numerator is telling us sec theta minus 1 and the denominator is telling us sine square theta. Now you need to bring them to their lowest form. With my previous video, I make you understand that, recall, sec theta can be written as what? 1 over cos theta. That is the inverse of what? Of cos. And also, if I implement this into the above expression, I'm going to be having 1 all over cos theta minus 1 all divided by what? Sine square theta. Now, if you look at the one is not standing alone, the one is like saying over 1. So if you look for the LCM there is what? Cos theta. Now, cos theta and cos theta is 1. 1 times 1 will give you 1. 1 in cos theta is cos theta times 1 will give you cos theta. So we'll be having 1 minus cos theta all over what? Cos theta. All divided by sine square theta. Now don't forget that sec theta minus 1, they are just one entity on their own. So close to it, we have what? In 1 close to it. So if I move it to one side, I'll be having 1 over sine square theta times 1 minus cos theta over cos theta. You can see that? Now recall, from your trig identity, we know that cos square theta plus sine square theta is equals to 1. So sine square theta will now be equals to what? 1 minus cos square theta. That is when the cos square theta is going to the right hand side. So wherever I see sine square theta, I'm going to put 1 minus cos square theta. So if I implement it, I'll now be having 1 all over sine square theta. Instead of writing sine square theta, I'll put 1 minus cos square theta. Multiply by 1 minus cos theta over what? Cos theta. Now if you look at 1 minus cos square theta here, it's as saying 1 square minus cos theta, and that is difference of 2 square. So I'm going to write 1 minus cos theta in brackets, multiply by 1 plus cos theta in another bracket, multiply by 1 minus cos theta all over cos theta. Now if you look at this very well, cos theta here will equate 1 minus cos theta here will equate 1 minus cos theta here. So we'll be left with what? 1 all over 1 plus cos theta multiplied by 1 all over what? Cos theta. But 1 over cos theta is sec theta, right? So we say 1 over cos theta is equal to sec theta. Now if I implement it there, I'll be having 1 all over 1 plus cos theta times sec theta. Now if I multiply both of them, I'll be having sec theta all over 1 plus cos theta, which is equals to the answer that we need to get the right hand side. So we say we have proved this. So it means that sec theta over 1 plus cos theta in the left hand side is equals to sec theta over 1 plus cos theta in the right hand side. So this is what is proved. So if you found this video helpful, please don't forget to click on the subscribe button. Thanks for watching.